Okay, so when we do these coordinate parallelogram proofs, it's important that we understand some of these formulas. We're going to primarily focus on finding the slopes of our lines when we're completing our proofs. Just a little bit of review. Remember, when the slopes are the same, that tells us the lines are parallel. When the slopes are opposite reciprocal, that tells us that the lines are perpendicular. Our slope formula, y2 minus y1 over x2 minus x1. Our midpoint formula, when we're showing that the diagonals bisect each other, we could use the midpoint formula. That's x1 plus x2 over 2, y1 plus y2 over 2. And if we wanted to show the segment lengths were the same, we could utilize the distance formula. So those are all possible formulas. Again, those are all review, nothing new from what we've done with our formulas. Now there are 4 methods that we could utilize to prove parallelograms that they are a parallelogram. And again, we're only going to focus on one of them. I'm going to talk about these 4 methods real briefly. Method 1 would be to show that the diagonals bisect each other. That would be using the midpoint formula. Method 2 would be showing that both pairs of opposite sides are parallel by finding the slopes. That's the method we're going to focus on right here, method number 2. Method number 3, we could show that both pair of opposite sides are the same distance. That would be using the distance formula. Or method 4, we could do a combination. We could pick one pair and show that they're parallel and that they're equal in length. So that would be using the slope formula and the distance formula. So even though we're just going to focus on this one method of finding the slopes, it's important for you to understand there is more than one way to show that a figure is a parallelogram. I've picked the easiest method, or what I think is the easiest for you. And if you find that one of these other methods is easier, then like I say, I'm not going to mark that wrong. Let's take a look at the first example here so you can get an idea of what we're doing with this. So they're going to give you 4 points. And the first step, to get the first point of the problem, you have to be able to plot the points correctly. So let's do that on this one. They tell us L is negative 2, 3. So I go left 2 and up 3 and plot a point. 4, 3, I'm going to go right 4 and up 3. Point M. N is 2, negative 2. And O is negative 4, negative 2. Once you plot your 4 points, we're going to go ahead and connect the dots and draw in our shape. Now, as I said, we're going to focus on the slopes. So when we're proving it's a parallelogram, we're going to find 4 slopes. We're going to find the slope of all 4 lines. So the first one, LM, and ON, I'm going to put those two together because they're sides that are opposite of each other. And then the other 2 sides would be LO and MN. Now, in order for us to prove that this is a parallelogram using the slopes, we have to show that each of these 2 pairs have the same slope. So let's start with LM. LM is a horizontal line. What would the slope of a horizontal line be? Go ahead. It's not 1. It would be 0. 1 would mean that we're going up 1 and right 1. So notice here there's no vertical change. If you look at line ON, hopefully you notice it too is a horizontal line. So it's also going to have a slope of 0. Let's move to LO. LO, if I start at the point O, I'm going to count up 1, 2, 3, 4, 5, and right 2. So the slope of LO would be 5 over 2. And if I check the line MN, if I start at N, I'll go up 1, 2, 3, 4, 5, and right 2. Also a slope of 5 over 2. Now, by showing those 4 slopes, I have now proven that this shape is a parallelogram. And the last part of this problem is you explaining that. You'd say this is a parallelogram because both pairs of opposite sides are parallel. Again, the slopes tell us that they're parallel. Bless you. So as we list these sides, let's go ahead and list the slopes. For QR, that's our top side. QR, I'm going to go up 2. Remember, you always want to start with your rise over your run. So rise first. So I'm going up 1, 2, and I'm going right 1, 2, 3. So hopefully you got a slope of 2/3 for QR. For PS, if I start at P, I'm again going to count up 1, 2, and I'm going to count over 1, 2, 3. So it also has a slope of 2/3. For QP, if I start at P, I'm going to count up 1, 2, 3, and over 1 for a slope of 3 over 1 or 3. And for RS or SR, if I count up 1, 2, 3, and over 1, also a slope of 3. So again, notice on this one, both pairs of opposite sides have the same slope. So yes, it is a parallelogram. I think it's real important that you understand how to state your explanation on these. Okay, we're focusing on the sides being parallel. So when you're making your statements, it's important that you make your statements about the sides. Okay, so again, does the slope tell us anything about the angles? No, so we're not going to say anything about the angles. Okay, does the slope in this case tell us anything about the diagonals bisecting each other? It does not. It's just telling us that the lines are parallel because they have the same slope. So being able to make your statement and your conclusion is probably the most important part of these problems, aside from you finding the slopes.